All right, guys, back at it again for part two. So this one, there's not a lot here. There's only like three problems, but some of them can be a little bit tricky. So let's think about just these real quick, okay? For the first problem, okay, and for the rest of these, you will need your you will need this, okay? The instructions are on the page. This is classwork day 4 instructions. Make sure you guys are watching that because without the instructions, it may be a little hard to find, okay? Especially for the later problems, okay? But for this one, it tells you angle ACB is 160. Okay, so like pretty chill. Central angle, so the measure of arc AB is 160. All right, that's not bad at all. Okay, but for the other two parts, I'm going to split apart just like how we did a couple days ago. Okay, they want the length of AB, so that's the arc length, and then they want the area of sector. All right, so I did a few of these already. You guys can totally be able to find this. I will say that both answers are fractions. Okay, so if you watch other videos, the examples, especially classwork part one, this shouldn't be too bad. But there are going to both be fractions. Okay, with pi at the end. All right, beautiful. So that's on you guys. Bye. All right, 10.6. So for 10.6, let's read what it says because it doesn't really say much. All right, let's read this because this is my boo-boo way of showing you. Okay, a certain, okay, we're going to do that. A certain car's windshield wiper clears a portion of a section. What am I saying? Okay, a certain car's windshield wiper clears a portion of a sector. So it's clearing the shaded part, okay? If the angle of the wiper pivots during each swing at 120 degrees, then find the area of the windshield that is wiped, okay? So that's the shaded part. So obviously we've never done when it's just like this part and not the full sector, okay? So the hint is you must find two areas and subtract. So that's my hint. So this is what would make the most sense to me is there's this big sector, the whole entire thing, including what we don't want, but there's the big thing. And then if you just kind of minimize this away, there's a very small baby sector right there. Little tiny guy, little tiny guy. So wouldn't it make sense if in our picture, which you guys could draw here, okay, there's the picture, okay, I'm going to draw it exactly. Here's 120, this is 5, and then this part is 15. Okay, and I only want this. Okay, so to find this and not this, wouldn't it make sense to do the whole entire total minus the mini piece below? Okay, so do the whole thing minus this, and that'll give me what I want. Okay, so we're doing area of sector. So that means I have to do the area of the full sector, the whole thing, and then minus away the area of this baby tiny sector down here. And that'll give me what I want. So let's do that. So the total, if this whole thing is what we're talking about, okay, the total for an area would be a fraction times the total area, right? That's going to give me this thing. So the fraction we have is 120 out of 360, obviously. And then if we're talking about the total area, if this were a huge, massive circle, that's pi r squared. Okay, but the radius, if this were a part of a big circle, is 20. Because again, the whole massive thing, that's a radius of 20, 15 plus 5. Okay, and then we'd be subtracting away the fraction times the area of the small side. Okay, if this, let's say this was my small little guy that I want to get rid of to get what I want. So that's still the same fraction, But now this is pi r squared, but the radius of this little guy is 5. So again, total minus, I don't want this ugly little elbow head right here. I don't want that. I want that to go by. Okay, so this is 1/3 times 400 pi. This is 1/3 of 25 pi. So it's 400 over 3 pi minus 25 over 3 pi. And nice, look, denominators are the same. So this is 375 over 3 pi, which equals 125 pi. And this is of the shaded, which is what I wanted. All right, hopefully that made sense. If not, sorry. Okay, beautiful. There you go. Let's go to the back. The back ones are fun. Back ones are really fun. Okay, ooh, this is where it gets fun. Okay, so that's me, the GOAT, greatest of all time. Hope you knew that. Here we go. Okay, so we are actually gonna do, which ones are we gonna do? Oh yeah, we'll do A and B. Okay, C, if you want to try on your own, that'd be really good. But these two are perfect for this. So these are test questions. These are like dope questions. So look what it says. Zoe the goat, sorry, this should say Mr. A. This should say Mr. A. Anzalone the goat is tied by a rope to one corner of a 15 by 25 meter rectangular barn. Okay, so think about it. There's me, the goat, tied to the corner of a barn, and the barn is 15 by 25, right, based on those measurements. Okay, look what it says. Over what area of the field can Zoe graze if the rope is 10 meters long? We're doing part A. Okay, so in this example, this rope is 10 meters long. So here's what you got to think about. This is the conceptual part here, is that if that rope is 10 meters long, all right, she's connected to that. He, Mr. A, is connected to that. So this goat, it could obviously eat in here, right? The rope is not like a hard rope. It could just eat here. But if this guy's trying to eat as much as he possibly can, he could start moving in a circle. Because again, he's attached to this rope. So imagine it's just like, that's how far he could go. The rope is 10 feet long. So the rope is going to go, since this wall is 15 and the rope is 10, he's going to start spinning in a circle, but at some point, he's going to hit the wall. Okay, he's going to hit the wall here. And this rope, again, is going to keep spinning until he goes there. Okay? Because again, imagine he's connected here, and it's just spinning. It's going to make a circle. Okay? So think about what we have here. We have a circle. And you may be wondering, how much of a circle is this? Well, think about it. If I split this circle into pieces, okay, and we have, this is our area, that is 3 of the 4 pieces of a circle, right? Because that would be the other fourth. So I have 3/4 of a circle, okay? And if I want to find the area of this sector, a big sector, it's 3/4 times the area will give me what that would be, okay? So area is pi r squared. The radius is 10, so this is 3/4 of pi of 10 squared. And 3/4 of 100 pi would be 75 pi. Done. Okay? So that goat, again, with the rope, that's the most he could eat. He could eat everything in here if he's attached to that rope. Okay? So here's the sad thing. This is the easy one. Okay? It gets worse because this goat is a savage. That's me, a savage. Okay? So what we have to do is move to part B. And if you were lucky enough to get to part B, I got a treat for you. Okay? Minion of the day, number 4. Okay? Did I already do a minion for day 4? Wait. I think I already did Dominion. Oh, sorry. Sucks. Okay, let's do part B. Last one. Oh, whoa, I ruined it. Okay, there we go. So, part B says the rope is now 20 meters long. Okay, that's how long the rope is. This is where it gets bad. Okay, you know that this side of the barn is 25. So if this rope is 20 and it swings over, he's going to hit the wall because the wall is 25, the rope is 20. Boom. So this homie is going to swing around, and he's going to probably get pretty deep in the wall because, again, the rope is 20. So let's say he goes there. So he could do that. But the worst part is that this guy with a rope of 20 is going to start going the other way with the wall that's 15. But if the rope is 20 and this is 15, he's going to get to the point where he's swinging around, 20 feet. And that rope is going to get going over the wall that's 15. Because, again, a rope is 20 and this is 20 and this is 15. There's 5 feet of rope up here that stops. Okay? So look what I got. I got, again, 3/4 of a circle. But again, a rope is soft. And if the rope goes up and there's 5 feet left up here, the rope gets caught here, and then it swings and makes a tiny piece here, where this is 5 feet. Hopefully that makes sense, okay? Because again, before, he hit the wall both times. Boom, boom, easy, 3/4 of a circle. Now, even though he hit the wall here, if he goes around, he's going over the wall, rope gets caught, boom, he could eat this little piece. So you got to think about this problem in two different parts. So this problem has the big part, right? But it also, we have to add in the little part. Okay, so in this problem here, this big part, just like before, is 3/4 of a circle. That's what the big part is. So this is 3/4 of pi r squared. Okay, and my r here is 20 of the big circle. And I could find out what that is. Okay, but my little circle up here, that is only 1/4 of a circle. Right, because again, it doesn't do the other 3/4, it's only 1/4 of a circle. Okay, 90 degrees out of the total 360. So it's 1/4 of pi r squared, but my radius of this little guy is 5. Because if the rope was 20 and the 20 is here, 15 is here, it's 5 feet of rope to make this little guy. And if I continue solving, that will give me my answer, which again is a fraction. And you guys could do that. Okay, part C is not on this page. Don't worry. I would try it out because it's a little tricky. But again, hopefully you guys can do well. If you have any questions, let me know. This is the end of day 4. Wow. Who would have known it would have gone this long? But again, you guys are rock stars. If you have any questions, let me know. Miss you guys. Peace out.